Hi everyone, welcome to the video on Le Chatelier's principle. Alright, first I'm just going to start with talking about what Le Chatelier's principle states, and then we'll start looking at examples. Alright, so if you have a system at equilibrium, so that means we have those double arrows in the forward and the reverse reaction, and equilibrium means the rate of the forward equals the rate of the reversed. Okay, we can disturb this equilibrium. So kind of think about it as this kind of a balance. So you can add, if you had a balance beam or a balance with two ends on it, you can disturb it, okay? So if we stress our system, our equilibrium reaction, the system's going to react, okay? And the direction that it's going to react in is going to be in the way to relieve stress. So just like we all would like to relieve stress in our lives, that's what these reactions do as well. So the equilibrium is going to shift towards reactants or towards products to try to relieve the stress. Alright, so here's some possible disturbances. So this is ways that we can disturb an equilibrium reaction. So let's say we've got a reaction in the pot and in our flask, and it's at equilibrium. Forward equals reverse, and we know that we have a certain concentration of reactants and products, whatever that might be. Okay, we can change concentration, we can change temperature, and we can change pressure. Alright, so here's our reaction. Okay, so what happens? Alright, if we increase concentration on one side, okay, what I mean by that is on the side of the arrow. If we increase concentration on one side, the reaction is going to shift to the other side. Okay, so if you increase on one side, we're going to try to balance it out. So if we increase concentration, we got to increase it on the other side. Therefore, the reaction shifts to the other side. What does that mean? That means that if you look at this reaction, if we increase CO concentration, okay, reaction shifts to the other side. Okay, that means we now have less oxygen and we have more product, CO2 molecules. Okay, chemists can use this to our advantage because a lot of times we want to make more product, right? So we can increase concentration and other factors and get more product, okay? Now, what happens if I decrease, okay, or excuse me, what happens if CO2 is increased? Okay, earlier we had CO, okay? If CO2 is increased, so if we increase the concentration of our product over here, okay, or for you guys, let's see, it'd be over here, okay, then the reaction shifts back to the reactant side. Okay, so if we increase on one side, it's going to shift to the other. Okay, so look at it this way. If we increase products, it's going to shift to the reactant side to kind of balance that out. So if you increase on one side to relieve the stress, you got to shift the equilibrium to the other side and increase it. Okay, so if we increase CO2, we increase here, reaction shifts to the other side. That means we have more oxygen molecules and more CO. Okay? Different reaction. We've talked about increasing concentration. Well, you can also decrease or remove molecules. Okay? So you want to remember this. Okay? If you increase concentration, the equilibrium shifts to the other side. Okay? If you lose concentration, then the equilibrium shifts to the side of the loss, right? So if you think about a balance, if you lose, then the equilibrium needs to shift to balance it back out. Okay, so you're going to shift to the side of the loss when you remove or lose or let or have less concentration. So if you look here, water is our product here, one of our products. Okay. If you remove water in the reaction, this could actually be a favorable condition if you had a way to pump water out of this reaction, because as you remove it, more and more is going to be made, because if you remove, the equilibrium shifts to the side of the loss. Okay, and so here we remove water and the equilibrium shifts to that side. So it's shifting to the product side, which means you're making more of your C2H4 here, ethylene, and the ethanol is decreasing, right? Because you're shifting away from it. So you're making more product here. Okay, concentration is one way that we can disturb equilibrium. We can also use temperature. So this can also be used to the advantage of a chemist to change temperature. Okay, and it works the same way. Okay, and I like to look at this. You've got to know whether the reaction is endothermic or exothermic. Okay, an endothermic reaction is what we have here, and it has a positive. That means it gained temperature. So I like to go ahead and just put that over here, whatever that, let's just put, we'll just pretend temperature, or you could write delta H equals plus 43, whatever. But temperature is really a reactant here, because you had to gain, okay, that's what endothermic means. So endothermic, your delta H, okay, it means you had to gain energy in order to produce products. So when the temperature is increased, the reaction that absorbs heat is favored. Okay? For an endothermic reaction, okay, it absorbs heat, so increasing the temperature favors the forward reaction. Okay? Because to me, I consider it as being a reactant here. If it's endothermic, it has to gain in order to produce products. So I just put it over there with my reactants, and I do the same thing I did before. If I increase temperature, reaction shifts to the other side. Okay, now if I decrease temperature in this example, then that means the reaction would shift to the side of the loss, to the reactant side. Okay, but here it's showing if you increase the temperature of an endothermic reaction, then the equilibrium drives to the other side. Okay, and exothermic is opposite. So what I do, if I know it's exo, then I put plus temperature or whatever, plus or negative 222 on this side, because it's a product. Because remember, exo means energy is released in the form of heat. Okay, so if I increase the temperature of an exothermic reaction, it's going to shift to the other side, just like if we increase concentration. So increased temperature drives the reaction to the left. Okay, if I decrease temperature, if I'm pretending this is a product here in an exothermic reaction, if I decrease the temperature, then the reaction has to shift to the side of the loss. Okay, if you increase, it shifts to the other side. If you decrease, it shifts to the side of the loss. Okay, for an endothermic reaction, I consider that temperature increase or decrease to be on the reactant side, because endo means gain, had to gain energy. Okay, and then for exo, it means energy is released. So I consider this to be on the product side, and then I do the same thing. If it increases or decreases, I shift the equilibrium from that. We can also change pressure. All right, when pressure increases, the equilibrium shifts in the direction that to the fewest moles, or decreases the number of moles. Okay, so this is something you just got to commit to memory. And so I usually say it over and over to my students. If pressure increases, you shift to the side of the fewer moles. If pressure decreases, you shift to the side of the more moles. Okay? So what is more and less moles? All you do is look at your reactants and you look at the coefficients. You have 3 plus 1, you have 4 moles, and here you have 2. You just look at the coefficients. So over here we have more moles. So if I increase pressure, I'm going to shift to the side of the fewer moles. So that would be this side here, the products. If I decrease pressure, I shift to the side of the more moles. So here's my more moles. I have 4 over 2, so the reaction drives to the side of the more moles. So you just have to remember those. So here's all of them put together, okay? And you can play with these, make up your own. You can make up your own scenarios and examples. But basically, if you add reactants, okay, you're going to shift to the products. If you remove reactants, you shift to the side of the loss. So you shift to the same side, so you shift to the reactant side. Okay, if you add product, you shift to the other side. Okay, if you remove product, then you stay on the same side. You're going to try to compensate for that loss and shift to the side of the loss. Okay, so it favors the products. And then for temperature, I look at it the same way. I just know for an endothermic reaction, I think of that temperature being on the reactant side, and for an exothermic, it being on the product side. Therefore, if I increase temperature, then I'm going to favor products for an endothermic reaction and reactants for an exo. And if I decrease temperature, I'm going to favor the reactants for an endo and the products for an exo. All right, pressure, you increase pressure, you shift to the side of the fewest moles. So you add up your moles. And then if you decrease pressure, you shift to the side of the more moles. Okay, you probably want some practice with this, so there's homework practice and practice in the reading, but I'm going to make a separate video over just some practice problems. So I would encourage you to do those and be sure you understand how the equilibrium shifts when we stress it, and we use Le Chatelier's principle to figure this out. So I hope this helps. Thank you.